Lesson 4.5, completing the square. Up to this point, we've learned about general form and we've learned about vertex form. We can convert from vertex form to general form by expanding our square that we have here, but going from general form to vertex form is a little bit more challenging. So in order to be able to do this, we need to be able to create this perfect square. So we're going to do that by what we call completing the square. So there's an activity to do first, so make sure that you've checked in with me and you've done the activity physically using algebra tiles to kind of set you up so that this will make a little bit more sense. I'm going to get you to put just a single line through this process because we do it a little bit differently than that. So we're going to cross that out like so. And the first example we're going to look at, we're going to start with using algebra tiles. So if you want to have a set of algebra tiles, go right ahead if you're in class. If you are at home, you can use this website that's up at the top. You need to use it on an actual computer, not just on your phone though. So that's the only kind of downfall to it. So I'm going to go to this website. So it says that I have 3x minus 12, or 3x squared minus 12x plus 7. So I'm going to start by just pulling those out. 3x squareds, I want 12 of these guys, 5. And then I want 7 ones. Alright, if you look at these tiles and you look at them yourself and you say, can I make a perfect square out of these? Well, we try building a perfect square out of all of them, but it gets kind of awkward in the sense that now we've got to fill this space and we've got to fill all the way around out here. So instead, we'll keep with modeling single x squareds as our perfect squares, and we're going to try and build perfect squares on that. Now I'm not going to make this absolutely perfect because that would just take up a lot of time, and I'm sure you don't want to spend all day just watching me move algebra tiles around the screen. But eventually I can make some perfect squares for these guys. Oh, you know what, I've done this a little bit. So you can move things around until you get them to work properly and make some what look like perfect squares. They're just like we have in the activity. We're going to have some discrepancies. We're going to have those holes in that bottom right corner. So I've got my squares, but I can't complete them. I've got 1, 2, I've got 7. They're not going to fill all these spots in. So instead I'm going to leave my regular 7 out off to the side. And I'm going to fill all my extra squares. But by adding all these extra 1s to fill these squares, make them complete, I'm actually changing my expression, I'm changing the values. So in order to account for that, what I need to do is actually add 0. So for every positive 1 I'm adding, I also need to add a negative 1 off to the side. Okay, same thing over here. I'm going to add 4 1s to complete the square. This isn't going to be pretty because I don't want to waste your time, but I've added 4 more 1s, so I'm going to add 4 more negative 1s. Add 4 more 1s. And so I add 4 more negative 1s. Okay, so So now I've completed the square. If I want to figure out my dimensions of that, it's going to be x and then plus, or not plus, but minus 2. And those are my dimensions to describe this square, and this square. Note the negatives to match the negative x's here. Okay, I'm also going to pair off these guys, and they are going to count as zeros instead. So even though I technically added these negative ones to correspond with the ones when I was completing the square, they're going to cancel out with the ones I had left off to the side, those original 7. Which means I've got 5 remaining negative ones that aren't paired off. The rest of these are all 0. So they all actually technically go away. So I've completed the square. So I've got 3 x minus 2 squareds and then minus 5. So what does this look like algebraically? Well, we go back over here. The first thing we do is we factor out that 3. And we're left with x squared minus 4x. And we leave that plus 7 on the outside. Now notice I've got this space here. That space is because I'm going to be adding in those extra ones. Now, as you've written on the back side of our activity that we did, we half our middle term and then we square it. So we take half of negative 4, which is negative 2, and then we square it to create our perfect square. So negative 2 squared is positive 4. But we didn't just add positive 4, we added 3 positive 4s. So to compensate for that, we're going to need to subtract 3 4s, or subtract 12, whichever way you want to think of it. From there, we know that this is a perfect square now. So it's 3, and my factor is x minus 2 squared. 7 minus 12 is negative 5. And now I'm done. That's my vertex form. Y equals 3 times x minus 2 squared minus 5. And that matches our picture that we created over here once we excluded all of these negative positive zeros. So we try again with B. This time we're going to be factoring out a 4. So it's x squared minus 7x, and then minus 23 in here. Because we've got a 7, this isn't going to be a pretty number, but we're still going to be able to do it. So 7 divided by 2 and then squared. And it's negative 7 as well. Divide by 2 squared. So that is going to be positive 49 over 4. But there's 4 of those fractions, so we've actually added 49 here, which means we have to subtract 49 on the outside. So my final answer is going to be 4, and then x minus 7 over 2 squared. And then also we go negative 23 and negative 49, so that's 60, negative 72. And again, we've completed the square. And that's all there is to it in terms of completing the square. It can get pretty ugly with some fractions, but the process still stays the same. The biggest mistake that people always make is forgetting that multiplier out in front to multiply what's inside here. Okay, some other things that we can use in order to manipulate our general form into vertex form is this equation here. This value, if we calculate negative b over 2a, that gives me my x value for my vertex. And then we can use this equation here to find the midpoint between my x-intercepts if I'm given my 2 intercepts. So we've already worked with this one. but we have never worked with this minus b over 2a. So to determine the coordinates of the vertex of the parabola with the equation y equals 3x squared minus 12x plus 7. Now this is actually the same equation as we used on the previous page, but we're going to double check it this way. So that first equation on our page here, that x equals negative b over 2a, that's what we're going to use. So equals negative b over 2a. Well, that's negative 12. So 12 over 2 times 3, which is going to be 6, so that is 2. And then my y value, I'm just going to plug my x value in and solve for y. It's going to be 3 times 2 squared minus 12 times 2 plus 7. So that gives me 4 times 3 is 12, minus 2 times 12 is 24, plus 7. And if we plug and chug, that gets 12, negative 5. So my vertex is at 2 and negative 5. If we go back to our first example, sorry we're scrolling around so much today, we get P is 2 and Q is negative 5. So that is my vertex. It matches what we found down here. So that's nice and convenient. 3, determine the axis of symmetry of this guy. So option 1 is we can use our negative b over 2a, or we could try and factor this out and see if we could come up with an answer that way. Either way would totally work. Because we're talking about axis of symmetry though, we're still talking about that x value, I'm still going to stick with this x equals negative b over 2a, because I'm not even going to have to solve for y here. So I can plug in negative 5 over 2 times negative 2, which is negative 5 over negative 4. That simplifies to 5 over 4, and that is my x value of my vertex, and therefore it's also my axis of symmetry equation. Here, to find the y coordinate of the vertex, I can do one of two things. I can find out my x value and then substitute in to solve for y, or I can complete the square. I'm going to complete the square just so that we get a little bit of extra practice seeing what that looks like. Here, I'm going to take out a half, which means I'm left with x squared minus 6x, and then minus 8, not 6. Okay, I'm going to take half of negative 6, and I'm going to square it. So that's negative 3 squared is positive 9, but I'm actually only adding half of that, and so I'm going to subtract half of 9, and I'm going to leave it in fraction form. From here, I'm going to write it in my completed square, so that's x minus 3 squared. 8 I can convert to 16 over 2. It's negative already, so 16 and 9 is 25, so it's going to be subtract 25 halves. I apologize for this whining in the background. That would be the dog. Okay, once I've done my completion of my square, this piece here is Q, and as we know, Q is our y coordinate of our vertex, so Q or y value is going to be negative 25 halves. And that's my answer for that question. So there are practice questions. I think we've got some flipping around of practice questions. So if you're looking at the ones that directly follow this lesson in your booklet, head to the questions after the next section. I think there's just been a little bit of a mixed up when I was moving questions around a little bit. So make sure that the questions kind of jive with what we just learned. Practice completing the square because it's definitely advantageous in terms of converting between general form and vertex form and finding out your vertex a little bit quicker sometimes instead of having to factor and then take the average of your intercepts. So good luck.